There are a handful of different study designs that you need to be familiar with, but let's start with incidence and prevalence of disease. Incidence looks at all the people who are newly diagnosed with a disease in a given period of time. It's typically a year. Compare that to prevalence, which looks at all the people who have the disease right now. So if this is everybody who can possibly have the disease ever, everybody who's at risk, and I want to look at how many people were diagnosed with diabetes this year. And it's this little segment right here. This is incidence of diabetes. Since diabetes is a diagnosis that sticks around for a while, it's a chronic illness, the number of people who have the diagnosis at any given period of time is going to be greater than the number of people who were newly diagnosed. So if I wanted to look at the total number of people who have diabetes right now, it would include the people who are newly diagnosed and then a lot more. It would look like that. So that would be prevalence of diabetes. All right, on to the different kinds of studies. We can broadly break up study design based on whether or not there is an intervention. An intervention is anything that a researcher does to people in the study. It can be a new medicine, it can be a pamphlet, it can be an old treatment, whatever. It's just something that the researcher does or gives to the people in the study. And if there is no intervention, what you have is an observational study. And this can be broken down even further based on whether or not your observational study includes a comparison. If there is no comparison, if you're just describing something, you have a descriptive study and it's going to be one of two that you need to know about. You have either a case series or you have a cross-sectional study. A case series is just what it sounds like. It's a series of cases. So this is something where somebody noticed a few interesting people who have a disease and they just wanted to describe it. You get you get qualitative information, not really any quantitative data, and it's presented as a narrative. So if a case series is where you just notice something, a cross-sectional study is where you start looking into a little bit more. You start asking questions. In a cross-sectional study, you ask a question of a group of people once at a single point in time. You can do this to assess prevalence. It's like taking a snapshot of traits of a group at that one moment. All right, on to observational studies that have a comparison group. We can break this down based on what are the groups that you're comparing. If you are comparing the same group of people repeatedly over time, what you have is a longitudinal study. And you can think of a longitudinal study as a series of cross-sectional studies. You send out a survey or something once to a group of people and you do it again, and you do it again the next year, and you do it again the next year. It's just a bunch of cross-sectional studies. And this is really useful for assessing change in prevalence. Okay, so for these next two, you have to actually start really paying attention, because the next two study designs that I'm going to talk about are the most important ones of the whole video. So if the groups that you're comparing are people who have the disease that you're looking at versus people who do not have the disease, so you're comparing based on disease status, what you have is a case control study, because cases are people who have the disease and controls are people who do not have the disease. And if you're comparing people based on exposure status, so whether or not they have been exposed to a risk factor, what you have is a cohort study. Now, both case control and cohort studies, they're both looking at the relationship between exposure to a risk factor and then the development of a disease. They are looking at this question from different angles. Let me explain a little bit. So the way that we like to think about disease is that there is some kind of an exposure. Maybe it's to a stressful home environment or it's air pollution, whatever. There's this exposure that happens, and then later on you develop a disease. We like to think of it with the exposure happening before the disease. In a cohort study, which is prospective, prospective means looking forward, you start with the exposure. You find a group of people who have been exposed to something, and then you follow them over time. And you ask, do they develop the disease? And all the while, you've also been following people who have not been exposed so that you can compare them. So in a cohort study, you are comparing two groups based on exposure status, and for people who've been exposed to a risk factor and people who have not been exposed to a risk factor, which group ends up getting the disease more often. And you do this calculation using something called relative risk. You don't need to know too much more about what relative risk is right now. Just try and remember that relative risk goes with cohort studies. So I'll explain a lot more about it in a later video. Okay, so an example of a cohort study might be something like finding a group of people who have chosen themselves to receive the flu vaccine and finding a group of people who did not get the flu vaccine this year. And then we follow them throughout the flu season and we compare among those two groups which group gets the flu more often. Compare that to a case control study. Case control studies are retrospective. That means they look backwards. So the group that we use here for case control is disease status. We start here with disease. We find a group of people with the disease and we ask them, think back in your history. Were you ever exposed to this risk factor? And we also ask a group of people who do not have the disease. So an example might be if we were looking at mesothelioma, which is great because it is a rare disease and case control studies are great for rare diseases. So we get a group of people who have the disease, who have mesothelioma, and we also get a group of people who do not have mesothelioma, and we ask both groups, do you remember being exposed to asbestos? And then we compare between those two groups how often they remember having the exposure. And we make this comparison using something called an odds ratio. And like relative risk, it's important, but we're not going to talk about it here. There's going to be another video. Just remember that odds ratio goes with case control. All right, so those are the observational studies. Just a note, observational studies cannot establish causation. So what that means is you cannot use an observational study to say that an exposure, a specific exposure, causes a specific outcome. You can only say that there's an association there. If you want to be able to say that an exposure caused an outcome, you need an intervention. And studies that have interventions are called experimental studies. And just remember that an intervention is something that a researcher gives to people in the experiment. If you want to have a good experiment, you need to also have something called a control group. And this is to make comparisons. So the intervention receives the thing, whatever it is that the researcher is giving the study group. This is what we're interested in studying. The control group receives anything except for the thing that we are looking at. Not the intervention, not the thing. So this can be a placebo, so people think that they are getting the intervention when they're actually not. It can be an existing treatment, usually the standard of care, or it can be nothing at all. The point is that it is not the intervention. And if you want to have a good experimental study, you should also have something called randomization. This is where you decide who gets the intervention and who gets not the intervention. And you do it just using random chance, like a coin flip. And that's how you assign the group, control versus intervention. And really quickly, I just want to mention a type of study called a crossover study. It's really cool. It's where people who were in the control group halfway through the study switch and receive the intervention. And likewise, people who were receiving the intervention switch and receive the control. And they cross over, so this is called a crossover study design. This is really cool because people act as their own control, and it is a great way to minimize bias. Now, bias is something that we haven't mentioned yet, but it's really important. It gets its own video, but the purpose of having a control group is to minimize bias, and the purpose of randomizing who goes to what group is also to minimize bias. Bias is bad. We want as little as possible. Okay, speaking of bias, how much bias an experimental study gets is kind of another way that we can break down experimental studies. So actually, we're going to be asking who gets blinded in our experimental study. And what blinding means is hiding the group assignment. And you can blind the patient so they don't know whether they are in the intervention or the control group, or you can also blind the researcher so they don't know which group the patient has been assigned to. So, if no one is blinded, if everybody knows what group they're in, if the patients know that they're getting the placebo or they know that they're getting the treatment, and the researchers know too, what you have is an open label study. Open label studies are not preferred because they have the greatest risk of bias because everybody knows what group they're in. But sometimes you can't avoid it, so you're kind of stuck. What would be better is if you can blind at least the patient, so the patient doesn't know whether they're getting the intervention or they're getting something else. This reduces the amount of bias, and this gives you a single blind study. So you have less bias here, but you still have some because the experimenter or the researcher knows what group. So better still is if you can blind both the patient and the researcher. This results in a double-blind study. These are most preferred because they have the least amount of bias of these three study designs. So to review, bias is bad, and in experimental studies, we use control groups and randomization and blinding to minimize bias. Within observational studies, there are two important study designs that you need to be able to tell the difference between, and those are case control and cohort studies. Look out for my video on risk to learn more about these. And that is study design.